Good morning, friends. Welcome to this video lesson. Today, we'll be discussing about the design philosophy and what are the factors that are required. What are the factors that we consider while designing a machine element. Basically, this topic comes under design of machine elements or machine design. This will be useful for both the diploma as well as engineering students. So today we will be starting with the basics of design of machine element. You know, every part of a machine element is very important. Right from the bolt, the screws, nuts to shafts, all these elements without which any machine can be operated. So therefore, these individual parts are very important, and the designing of such parts plays a very vital role in assembling a big machine or any instrument for that matter, for any product. Therefore, we will be discussing about the basic fundamentals of design of a machine element. First of all, let us see design philosophy. What do you mean by design philosophy? First of all, what is design? So design have a broad sense, or design has a broad meaning. So based on the profession, people will take a design in different manners. An architect will use a design in different manner. A civil engineer will use a design in another manner. A mechanical engineer will use design in another manner. And also an artist will use design in another manner. So design have a connotation, but our specific idea is here. We will be defining, or we will be discussing about the design in the perspective of engineering background. So engineering drawings or the plans, all these things constitute design. So let's get started with this design. So I have a PowerPoint presentation with me. So I'll share that PowerPoint presentation. Accordingly, we will proceed. So I am here with sharing the PowerPoint presentation that I have prepared. So here we go. Okay. Introduction to design of machine elements. Yes, this is the topic. So my name is Anand Padavala. I'm senior faculty member in the Department of Technical Education, Government of Telangana. I take classes for diploma students of mechanical engineering. Of course, this is not only useful, this topic is not only useful for diploma students, but also for engineering students. So those who are in need of this topic, they can refer to these videos, and also they can subscribe my channel. So let us get started with this design of machine elements, introduction to design of machine. Design philosophy. So what is it? Since evolution of man, his desires are many. Yes, true. So if we take this one from the evolution, when Homo sapiens, that is new evolution, during the evolution of man, he has specific desires and specific needs. So there are many. So he used to do something to satisfy his desires. So he designs tools for hunting. Yes, hunting. Why hunting is required? So to get livelihood. So he used to hunt the animals, and by eating them, he used to get energy. So it has become a basic need, necessity for them to have a tool. So he designed according. So earlier they used to use blunt stones. Then they started sharpening those tools, sharpening those stones, and they started tying an axe or one big log or a handle to that stone. So all these things he has designed, and the reason for the design is need, and he wanted to move on roads faster, a little after. So he wanted to move a little bit faster. So he invented a wheel. So he designed fast and accordingly has done. So here he designed, he wanted to do that because he has some desires and he has some specific reasons for that, because he can do the things very fast. So this is what. So the idea behind the design for these wheels and all these things are desires. And he developed many means of transport because of this thing. If you say modern machines, modern transport, car, bus, cycle, all these things are the inventions of man, and he designed and developed all these things. And he wanted to fly like a bird. See, he was in the nature. He was looking at the nature. Of course, flying is not his duty, and he is not supposed to do that because basically he is not having wings. But by he admired by seeing at the birds, so he wanted to fly like a bird. So he invented air means. So the present day aeroplane, helicopters are the inventions because of his ambitions. He wanted to fly like a bird. So all these things. Here the design, the reason for this design of these machines or these transport things is because of his ambitions. So therefore, the basic requirements of a design are need, desire, and ambition. These three things are the basic requirements for any design. So design is because of a need, design is because of a desire, design is because of an ambition. And this design is converted into products. So in order to have a product, first he should have some idea how to do what to do. And he will have some designs. And basically those designs will be converted into products. So the basic requirements for a design are needs, desires, and ambitions. So design is essentially a decision-making process. Yes, definitely. If we have a problem, we need a design. We need to design a solution. So when there is a problem, then only we will think of a solution. When there is no problem at all, no one will bother about that. So as long as problems are not there, the entire world, for that matter, humankind, will be standstill. So because we have day-to-day problems or issues, so we have to have some solutions. In order to get solutions, we design a solution. So this is what. In other words, to design is to formulate a plan to satisfy a particular need and to create something with a physical reality. Yes. So design is nothing but formulating a plan. Why to formulate a plan? To satisfy a particular needs. Why to satisfy a particular needs? Because it's creating something. Because there is a problem, and it will create something with physical reality. This is what a design philosophy is. So let us consider an example. We want to design a chair. We want to design a chair. A number of factors are needed to be considered first. Suppose I want a chair. So if I want a chair, why we want a chair? To sit. So basically, so many things we have to consider when we want to have a chair. So what are these? What is the purpose for the chair? Is to be designed such a way that whether it is to be used as an easy chair, it is an office chair, or accompanying a dining table. What is the purpose of that chair? That comes first factor. Second factor, whether the chair is to be designed for a grown-up person or for a child. For a child, the size will be small. For a big elderly person, the size of the chair will be a little different one. So basically, to whom we are designing it. Next, material used for the chair. That means with which material we have so many options. We can make with the wood, we can make with plastics, or we can make with even diamonds. Also, we can make it. But the material selection, this material selection is based on the strength requirement, the cost, all these things comes under when we talk about the material. So material is another factor. And finally, aesthetics and design. So how it is looking like. Even it may be above 3 may be essential. Some may think that this is not essential, but nowadays aesthetics of designing of anything has become predominant because people are buying the products because of just aesthetically it looks good. Apart from satisfying the what I've said, the three factors. So these are the factors that we have to consider when we design anything. In this matter, we are thinking about a chair, but if you take any product, we have to consider all these factors when we design a product. So in one way or other, in our daily lives, because problems are posed and they need to be solved. So because there are some problems, we have to solve these problems. That's why we need solutions for that, and we have to design to get that product. So let us try to define a machine design, because design can be in many areas, but we are talking about design of machine elements, particular to mechanical engineering. So let us try to give a proper definition for machine design. Machine design is defined as the use of imagination, scientific principles, and engineering techniques to create a machine structure economically in order to satisfy the requirements of a customer. Oh, what a beautiful definition it is. Yes, machine design is defined as the use of imagination. First, you have to use your imagination, how it should be. And after getting the imagination, you should use scientific principles and engineering techniques to create a machine structure. And this machine structure should be economically, because very high cost, it may not be affordable by the customer. And also it should satisfy the requirements of the customer. And for what purpose it has been created, that purpose should be served. So that is what a machine design. So machine design in the first step involves in creation of a machine. So when we talk about a machine, so this is the first step of a, so whatever is not there that we want to have, then is the first step is design. So it gives a basic idea of how a machine will look and function. So it will give a basic idea. So this is what a definition of a machine design. Now, we have some traditional design methods. We will go through it. There are basically two traditional methods in design. Design by crafts evaluation and design by drawing. What do you mean by design by crafts evaluation? Let us see. So design by crafts evaluation means the features of these old age techniques are as follows. Craftsmen do not prepare any dimension drawing of their products. They cannot offer adequate justification for a design they make. So traditionally, our forefathers or earlier generations, they used to make so many goods. They used to produce so many products, but they don't have proper dimensions or drawings for that. So they used to prepare based on their experiences, based on their imagination, and they don't have adequate justification why they are designing or making like that. So this is called design by crafts evolution. These products are developed by trial and error method. Yes, because they don't have any prerequisites, so they don't have any drawings and designs. So they used to make trial and error by many centuries. Any modification in the product is costly because the craftsman has to experiment with product. So in this, whatever they taught from their forefathers or from the centuries together. So based on the trial and error methods, they used to do experimentation. So moreover, only one change at a time can be adopted, and can complete reorganizing the product is difficult. In this thing, general traditional method, a small modification, generally he has some technique of doing a product or designing of product. He may go through one or two small changes, but he will not generally go for an entirely new one. So there is what it is. So the essential information of the product, such as materials, component dimensions, manufacturing methods, and assembly techniques, is transmitted from place to place, from time to time, by two ways. There is no symbolic medium to record the design information of the product, because so whatever the components they have used, methods they have used, assembly techniques they have used, they vary from place to place and time to time also, because of variation of generations. But there is no symbolic medium to record the designs. They used to learn from their forefathers. That's it. This is what a traditional design method called design by crafts evolution. So best example is bullet car, rowing boat, musical instruments are some of the product produced by crafts evolution. Second one is design by drawings. Essential features of the design by drawing methods are as follows. So the dimensions of the products are specified in advance of the manufacture. So they used to design dimensions of the product are specified in advance to the man. That means before he goes for a manufacturing process, so the design is ready and it will be in the form of drawings or documentation. So this is what it has. So the complete manufacturing of the product can be subdivided into separate pieces, which can be made by different people. So earlier, generally a person who starts doing that crafts method, he only used to complete because he has some idea how to do and what he has done. But here, when you have a design by drawing, you can segregate, subdivide the entire production process into different pieces, and these different pieces can be done by different people because they have what to do. They will be clearly indicated in that drawing. So the division of work is not possible with crafts evolution. When the product is to be developed by trial and error method, the process is carried out on a drawing board instead of a shop floor. So this is what. So the drawing of the products are developed prior to manufacture. So this is the difference between. You will have a, simply we can say that in design by drawing, you have a pre-plan, what to do, how to do and everything in the form of a documentation or a drawing. Whereas in craftsman, it will be in mind. There won't be the person who will be doing that only. He will only have that idea, and he will also do by trial and error methods because according to the situation, according to the material, he will go and what with experience that will come. So, what are the various types of designs we have? We have three types of designs. We will go one by one. So, one is adaptive design. What do you mean by an adaptive design? Design makes minor alterations or modification in the existing design of the product is called adaptive. So adaptive design means there will be a design, and what we will do, we will get another design, new design by altering or modifying the existing. For example, I have a pen, and this pen, by increasing its length, already design is there, by increasing its length or by decreasing its length or by changing the cap position, we can make a little modifications to the existing design. Thereby we will get a design. This is called adaptive design. Example, use of fiber body instead of metal body in automobiles. Yes, definitely. Earlier we used to have metallic bodies. Now we are replacing metallic bodies with the fiber bodies. So a little alterations in the material. So it is an example of adaptive design. Second one is developmental design. Developmental design. Development, what do you mean by developmental design? Here we start with the existing design, but finally a modified design is opted. So here also we'll start with the existing design, but the modifications will be more for the existing. And finally, when we arrive, there will be lots of changes from the original design. So in the adaptive design, minor alterations. In developmental design, we have major modifications. A new model car is typical example of developmental design. Already we have an old model car, but by changing its dimensions, by changing the purposes, by changing the number of persons sitting inside, all these things we can make so many changes. By its air resistance and all these things we can change. So then it is called a developmental design. So here you have number of modifications will be many. What is a new design? So as the name indicates, the design which is not existed earlier, it's a new design. So this type of design is an entirely new one, but based on existing scientific principles. So we use the existing scientific principles, but this design is not there earlier. So scientific inventions is not adequate, but no science, but requires creative thinking to solve it. So we, by using the same scientific principles, but we design with the design which is not there earlier, then we can create by to solve a problem. Then it is called new design. So basically, we have three types of designs: adaptive design, developmental design, and new design. Adaptive design and developmental design based on the existing designs, but in adaptive design, we have minor alterations, modifications. In developmental design, major alterations and modifications. In new design, entirely a new design will be uh, entirely a new concept, new design will come into picture. These are the types of design. So example for new design is a type of design may include designing a small vehicle for transportation of men and material on board of a ship or in a desert. So this is entirely new one. Types of designs based on the methods. What are the various methods we have? So we have two types. One is a rational method. What is a rational method? This is based on determining the stresses, strains of components and thereby deciding their dimensions. So rational method means rational approach. So we will calculate all the stresses and strains on the components and based on we will design. That is called rational design. Empirical design. Empirical design means this is based on empirical formula, which in turn based on experience and experiments. There won't be any basic formula for this. So, for example, when we tighten a nut on a bolt and the force exerted or the stresses induced cannot determined exactly by exactly. So, when we tighten a bolt on a nut or tighten a nut on a bolt, so the force will be exerted. So how much force it will exert, we cannot calculate, but with experience, we can say that it is P equal to 2840, in fact, 2840D, when D is the diameter in millimeter, for 2840D. D is the diameter, the nominal diameter of the bolt in mm. And the P should be applied force in newtons. If we have 2840, it is newton. If it is 284, we can say approximately it is in kgs. So there is no mathematical background. How we get, there is no proof that P equal to 284D. We don't have any proof for that. But based on the experience and observations, we came to conclusion that P is nearly equal to 284D. This is called empirical design. Third one is called industrial design. These are based on industrial considerations and norms. For example, if we take a market survey and external look, production facilities, low cost, use of existing standard products, and all these things comes under industrial design. So these are based on industrial considerations and norms. So these are the three types of design based on methods: rational, empirical, and industrial. Excuse me. So now we'll come to the what are the factors to be considered in machine design. So the design, when we design a product, when we design a machine element, or when we go for a machine design, then we have to consider some factors. So what are those factors that we have to consider? We'll go through. There are many factors to be considered while designing a machine element. Some of these factors are I have given here, important one. So device or mechanism to be used. So material, force or loads on the elements, size, shape and space requirements and weight, the method of manufacturing process and how it will be operated with ease or without ease, reliability and safety aspects, maintenance, cost and aesthetics of a designed product. So these are the 8 factors. We can put some more factors also, but these 8 are very important factors to be considered when we design a machine element. So we'll go one by one in detail. First one, device or mechanism to be used. So this is best judged by understanding the problem thoroughly. So which type of, to manufacture something, some product. For example, you have a phone like this, smartphone. To manufacture this thing, we have so many mechanisms are there. So which one we have to adopt? That is basically by understanding the problem. So based on the component that we produce, based on the solving the problem that we have, so we have to choose a device or a machine or a mechanism that has to be used when we fabricate. So something, a particular function can be achieved by a number of means or by using different mechanisms, and the designer has to decide which one is the most effective under the circumstances. So we have so many ways to solve the problem, but which way we are going is obviously should be decided by the designer based on the function. Next, material. So this is a very important aspect of a design. So a wrong choice of material may lead to failure. Over or undersized products are expensive items. So you know that material plays a vital role in design. For example, I have a duster. So when I talk about a duster, which type of material that I have? I can make a duster with wood and some dusting material by gluing them, or I can use a iron box, iron handle, and I can use the gold handle also. But which one serves the purpose? And the choice of material is thus depends on the suitability of the properties of the material of each component and their suitability of manufacturing and the manufacturer and the cost. So these are the things. When we choose a material, so which type of material use, that depends on whether that material is suitable, the properties of that material suitable for the components that we use, whether they are suitable for fabrication, or that means machinability, or what is the cost of that material. All these things matters when we design. So material is a big factor to be considered in machines. Next one is forces or loads on the element. Yes. So when we design a machine element, what are the various forces acting on that material, or various loads that are acting on that material that we have to see. So the external loads cause internal stresses in the element, and these stresses may be determined accurately since they will be used in determining the components. For example, I am manufacturing a bolt, and this bolt will be subjected to external loads or some forces, and this bolt should in a position to withstand those forces. So we have to have what are the elements or forces, the forces or loads that are acting on that particular element, that we have to see. accurately. Because if we make a undersize or which cannot bear the load, then it is going to be failure. Or otherwise, if we have make very strong material, even though it's not necessary to bear that strength, it's a costly affair. So that's why forces and loads on the elements are a very important factor. So loads may be due to energy transmission by machine members, or dead weights, or inertia forces, or thermal effects, or frictional forces. So these may be because of these are the loads or forces that act on a machine element. They may be dead weights, inertia forces, thermal effects, and frictional forces, and all these things. So these are the forces. And the loads may be either static or dynamic. Some of the loads are static. Static means the magnitude and the direction of that load will not be changed. So it will be like that only. That means it is static. But if we change the direction, either we change the direction or change the magnitude, then the weight will become a dynamic. So these loads may be either static or dynamics. Based on that, we have to identify what are the loads, whether it may be static or dynamic, which is acting on that particular machine element before we design. Now, size, shape, space, requirements, and weight. This is another factor. So preliminary analysis would give an approximate size. Generally, we think that the size of the particular element is this much. But the standard element is to be chosen. So the next large size must be taken. For example, I have calculated that a bolt of 21.23 mm size of diameter, nominal diameter is required. But that is not 21.33 bolt is not available in the market. So what you have to adopt? You have to adopt in the next highest. That is either you have to take 22. If 22 size bolts are not available, then we should go for next one, 23 or 24. So based on the availability, that size has to be determined. Shapes of standard elements are known, but non-standard element shapes and space requirements must depend on the available space in a particular machine assembly. Yes, this is true. So when we talk about shape of a standard elements that are known, but non-standard elements. So based on the space we have, based on the shape, we have to choose accordingly. And a scale layout drawing is often useful to arrive an initial shape and size. Yes, this is what we have. And weight is important depending on application. Yes, because if you take an example, an aircraft must always be made light. Why? It has to fly. So this means that material chosen must have a requirement of strength, but yet be light. That's why aluminum products are used. Though it has a strength, but it's light in weight. So the basic purpose here is aircraft, they should have a less load, that is less weight it should go. So this is what we have. And the fifth factor is method of manufacturing process. So we know that we do have different manufacturing processes to produce a product. And these manufacturing process varies from one product to the other product. So care must be taken to ensure that the design of elements may be designed elements are be manufactured with ease within the available facilities and not at higher cost, but it should be at low cost. So every care we have to take to ensure that the elements must be manufactured with ease and within the available facilities at low cost. Now, how will it operate? So basically, it is the final stage of the design. A designer must ensure that The machine may be operated with ease. For example, if you take in many power operated machines, a simple matter of pressing knob or switch is used to start the machine. So with what ease we are operating, that means whatever the product we make, finally how whether it is going according is it easy for operation or not, or easy for use or not. However, in other cases, a sequence of operations to be satisfied, this sequence must not be complicated and the operation should not require excessive force. So this is what we have. And consider the starting, accelerating and stopping a scooter of a car. With time-tested design consideration, the sequence have been made more easy. Earlier, in order to start, we used to have a kick button. Now it is replaced with the button start. And acceleration also. Automatic acceleration has come. And stopping also. More powerful brakes have come. So all these things, if we can do easily, then it is going to be a good design. So this is what we have. So how we will operate means whether what are the product that we have designed or a product is produced, whether we can operate that one with ease or not. That's what. Now, reliability and safety. What do you mean by reliability? Reliability is an important factor in design. The designed machine should work effectively and reliably. What do you mean by reliably? The probability that an element or a machine will not fail in use is called reliability. When a product is made, when it is not fail, when it is in use, then it is called, then we can say that it's a reliable material. So reliability, very important factor, because the machine failure because of the machine elements, so that should not happen. So we should think that the work should, machine should work effectively and reliably. So an overall safe design approach and care at every stage of design would result in a reliable machine. So every design approach of every stage and at every element, if we can take every care, then we can produce a reliable, relatively reliable products. Safety has become a matter of paramount importance these days in design. Yes, whether our design is safe or not, that is the machines must design to serve mankind, not to harm. So when we make a machine, it should serve the mankind, but it should not harm the mankind. So that's what safety has become very predominant, important. So industrial regulations ensure that the manufacturer is liable for any damage or harm arising out of the defective products. So this is what we have. So use of a factor of safety only in design does not ensure its overall reliability. So by using a factor of safety, it will become, it's not possible, it's not correct. So apart from the factor of safety, so many other things we have to consider. Now, maintenance, cost, and aesthetics. What are these maintenance, cost, and aesthetics? What are you want to say? Maintenance and safety are often interlinked. Yes, definitely. Maintenance safety. The good maintenance ensures good running condition of a machinery. Often a regular maintenance schedule is maintained and a thorough checkup of moving and unloaded parts is carried out to avoid catastrophic failure. So we know that members or parts that are subjected to wear and tear should be maintained properly. That means we have to check whether those parts are undergone wear and tear, whether it still can be used or not. So this checking up is nothing but maintenance. So the cost also, for example, if the unmaintained parts are there, they are not maintained, then after some time it will be, they will fail and we cannot use those parts. So by simple maintenance, we can use, I mean, we can go for, we can avoid a catastrophic failures. And low friction and wear is maintained by proper lubrication, because wear and tear is there. So low friction or wear is maintained by proper lubrication. This is a major aspect of design, since wherever there are some moving parts, friction and wear are inevitable. Yes, it's true. So high friction leads to increased loss of energy. Wear of machine parts leads to loss of materials and premature failures. This is the reason. That's why we have to have a proper design of the moving parts. And cost and aesthetics are essential consideration for product design. So cost is essentially related to the choice of material, which in turn depends on the stress developed in a given condition. And cost definitely matters a lot in consideration, as I said, because based on the material, based on the cost of product. And aesthetics also, aesthetics is nothing but how it looks. That is very important. Just I would like to give an illustration. When I tried to purchase a television 10 years ago, then it was LCD television was there. LED was just upcoming. So when I purchased that LCD TV, there are two models are there. So I have to choose between those two models. There are several models, but I like those two models. So out of those two models, when I checked for configuration, that means the size, the picture quality, audiability, and all these things, same are there. Both have the same properties. That means both the models have same qualities of the size of the TV, and the size, the video quality, audio quality, and everything. Both are same. But only thing is, appearance wise, one is looking bit beautiful than the other one. The appearance of first television is a little more beautiful, and the frame that it is given in black color has enhanced its look. And also it is looking as if bigger than the second one, because though the size is same, just because by adding a frame, black frame to the entire thing, it looks, it started looking like a bigger TV. So and when I ask the price comparison, the first one, with what beautifully it is looking, has 3,000 more than the other one. Though the main purpose is picture quality, picture size, and everything are both are same, when both will give same sort of satisfaction when we hear, but because of this aesthetic appearance, because of its good looking, it has 3,000 rupees more. And finally, when I am supposed to take a decision, I voted for the first one, though it is costlier than the second one. Because aesthetics, good looking, is also a matter to be considered, especially in present day scenario. The aesthetics are very important. So these are the many factors that we have to consider when we design a machine element. So although in many cases aesthetic considerations are not essential aspect of machine design, sometimes earlier, ergonomic aspects must be taken into consideration. For example, ergonomics means it should not have an effect on our body position. When I have a chair, sit in front of a laptop or any system, it should give a comfortable position. And when I operate the keyboard, all these things, it should be convenient. And because of this thing, suppose I use only a smaller chair or any different chair, that way I use for eat food. The dining table chair, if I use, then I may get a strain on my back and on my arms, because of the ergonomics of a dining table chair is different from the ergonomics of a computer table chair. So that's why you have to think of ergonomics when you design a machine element. So aesthetics are not that important, but people are asking for aesthetic looks. But even if you don't consider the aesthetic aspects, but you have to consider the ergonomics aspects, because they something to do with your comfort, and you can use that one. For example, if I have a TV and my eyes are getting strained because of its design, then it is a failure TV. The design is failure one. So it should give comfort to my eyes also. So it should give comfort. If I make a sofa set, it should give a comfort to me. So it should not strain my body like that. So these are the factors that I have to consider when we design a machine. So these are the factors, and there are other factors also, but we will not be going through in detail. So we'll stop here, and we will be discussing some more. That means this topic, design procedure, how to design a product, in the next class. But these are the things that we have to consider when we design. So in this class, we have discussed about the basic design philosophy, and the definition of a design, and also we have seen what are the various types of designs we have, like traditional methods when we talk about design by crafts or design by drawings, when we talk of the types based on the empirical formula or industrial applications and all these things. And also we have three basic designs: adaptive design, developmental design, and a completely new design. So all these things are very important when we talk about design of a machine. So friends, I hope you have enjoyed this lecture, and this is very much useful for the diploma as well as engineering graduates, students. So if you like it, please share subscribe to my channel, and please share this video with your friends or who are in need of this topic. This comes under design of machine elements or machine design. Thank you very much for watching this video.